Okay, we're on air.
Cool.
Okay.
Sweet.
So that's really where we should start. Did you guys have any questions on the homework?
A few questions.
I was kind of confused, so
Yeah.
this could be interesting.
Yeah. Let's see. I never really understood what the X bar means.
X bar, that's
Six.
population, the sample mean of the population.
Oh, okay. Sample mean. Okay.
Yeah, it's just the sign I use for it.
Oh, okay. All right. So the X. Oh, so the X bar is like that little line that goes over the X, or a little symbol. Or...
Yeah.
Oh, okay.
Because that's how I took it.
Right. Right. Anything else? I think for the most part, I sort of got the concepts. Just some things were a little weird.
Yeah.
Yeah. Like the X bar, but now that makes sense.
So, with part 2 under 7C, what does the mean sample mean appear to be unusual? Like, how would you know if it was unusual if your mean wasn't in the middle? Because don't you usually put the mean in the middle?
Well, it's going off the numbers that you picked up, right? So you could randomly have an unusual one. If you picked like ridiculous numbers.
Mm-hmm.
So it's unlikely for it to be unusual, but it can be.
Right.
So like for mine ended up as being 47,840, which is like right slap dab in the middle.
Right.
Yeah.
Right.
But unless you picked like 559,000 each time, it's gonna be better.
Right. Yeah, I got
Mine was 4330.
4330.
43,300.
Yeah, that was pretty close to what I got. I had 4,400, 44,000. So it's just a little above.
Yours are kind of on the lower end.
Yeah.
So is it not the same middle, or is it the population mean that goes in the middle?
Maybe it's the population mean, from what I understand. I mean, because all those numbers are the possible means that you could have gotten, and so the mean of the mean is kind of close to what Jay got. At least that's my take on it. But,
that's what I understand.
Yeah. Yeah.
Okay. So, as the population mean is the one that, like, you draw your thing down the middle and you get away from it. And then the sample mean or X bar is one.
Sorry.
Yep.
Okay. So how would you find the sample mean on number 8?
Sample mean number 8. I think they just tell you, because I looked at the answer sheet, and it's just the mean that the problem tells you of 529. So unless. Oh wait, you're looking for the sample mean? Just kidding.
Yeah, for D.
Sure. For D. Oh, got it. Okay.
Or not the standard deviation, because I can find the standard deviation. I guess it's
Right.
C, because it gives you the population mean, and the standard deviation, and the simple random sample, but it doesn't give you, like, how do you find the sample mean if you don't have any numbers to base it off of?
Let's see. So what I ended up doing, and of course I needed the little help from the answer sheet, but what I ended up doing was taking the standard deviation, dividing that by the square root of 10, because that's the what's it called? The simple random sample, or n equal 10, whatever that is. I forget what it's called. Basically, 113 divided by the square root of 10, and then that is how you get the sample mean.
Because it does give you a sample, like you said, at the very end.
Mm-hmm. That makes sense.
I think so. So you said you did like 113 divided by the square root of 10?
Yeah. 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 It doesn't really highlight it that well, the equation, like in the on textbook, but it's in there. It's kind of easy to gloss over and stuff, but.
Okay. I think that was the only questions I had on there. Like, the rest of them made sense for the most part.
Yeah.
It was the shortest chapter we've had to read so far.
Yeah. True that. So, yeah. So I guess we'll just go to the proof assignment then.
Yeah.
All right.
Yeah, we should be good to do that.
All right, I'm in.
Me too.
Cool.
All right. Okay, I'm into the quiz.
All right. So, question 3. Weird. It says, when taking samples of n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed? I would
If it's
want
right skewed, there's an outlier on the left. Because, like, if you were to look at the bell curve, the right skewed. Yeah, when you look at the bell curve, like the lump is on the left side, which means it's like there's an outlier to the right.
Mhm.
So if it's right skewed, there should be an outlier.
Yeah. So, samples N5.
So if the parent histogram is right skewed, I would assume that the sample from the histogram would make it skewed right as well.
Skewed right, yeah. Yeah, I mean, do you think we'll need that that little graphing tool that we had to use for the?
I have
I
no
don't have a
idea.
link for it, I'm pretty sure if I need it.
Sure. Whatever. Yeah, I just say it's skewed right.
Yeah, that's where I'm at too.
Yeah.
Let's see. Okay, number 4 then.
So it's skewed right.
Skewed right. Symbols.
I think we're supposed to be
Number
using
4.
something. Because it's the same thing.
Yeah.
We're supposed to be using a histogram.
Let me see if I can get that little graph thing pulled up and check.
Yeah, I'll do that too.
I don't remember where to find this histogram now. You're just in the last chapter, right?
Chapter 6, yeah.
Oh, wait a second. I think she emailed me something.
She did?
Yeah, I think she emailed all of them. Okay.
Well, that
She was
is
talking about
Cameron, you can
paper
help.
assignment, and I didn't really read it.
Yeah, I can hear you saying.
Oh, Jose! Like one of the 90s punk rock English bands, whenever they like say their name, like super annoying during the song. Oh, Jose!
Okay, yeah. I'm actually in a class right now, but
Oh,
yeah. Thanks a lot.
oh, Jose! Can they hear me?
Yeah, I think they can hear you.
Joel, I'm putting your band's name
Did
out
she
there.
email it to us?
I'm trying to put my internet's all of a sudden slowed down a bit.
First impression will be with a bunch of people who do not want whose band name is the last thing they want to hear. I'm publicizing your name, but it's too.
It's still pulling up.
Yeah, my computer doesn't really like to load when I'm doing lots of things, so this could take a while.
Right.
Oh, crap!
There we go. It's fine now. No, the thing she sent us is just an extra video.
Uh-huh.
For the correct assignment. I had nothing to do
Oh, it's
with
just
it.
an extra video?
Yeah.
I know there was something in the homework page that was like, go to here and do this. So I wonder if it was...
It was a little tutorial thing I did.
Mm-hmm.
Oh, it's just that chart. Okay.
The hardest part about this class really is finding what we need to use and then finding it.
Yes. But isn't the bigger the sample, according to the central limit theorem, that the bigger the sample, the more normal the distribution is?
Yeah, but if
Yeah.
it's still skewed right, wouldn't it still be skewed?
Yeah, I would think so. Yeah.
I don't know. That's what I'm trying to figure out. So are we saying for number 4 that it's still going to be skewed?
Because all the questions are basically like that. I don't know if it's just we're supposed to go through it that fast or we're supposed to have something.
Yeah. I mean, yeah, even like the individual prep, I mean, you know, when I would say, like, oh, when the parent population is, like, normally distributed or right skewed, it always, that was, like, the answer was, it's a normal distribution. So, I mean, yeah, this could just be one of those questions where it's, like, super easy and stuff. But
And
I
we're
guess,
just
yeah, it's always good to
overthinking.
check. Perhaps, but then again, it is always
Maybe
good
not at
to
the same
check.
time.
Yep.
Distributed or distributed.
It says in the friends that we're not using.
It says what?
It shows 4 different graphs. I guess I'm gonna look at it again. If it's skewed. Oh, I guess if you do pull it up, it does give a little graph thing, so you should pull it up.
Okay.
Well, it's like poop. Always smell poop. Hey! Hey, you like my short boot combo? You found your socks? You on your socks? It's fancy though. Work shorts with boots. Do any longer socks, you think? Short. I wear long slots actually boots because the top of the boots are gonna run snakes. Yeah. Did Aubrey say anything to you yet?
Yeah.
I haven't seen her today.
Do you think she knows?
Fine.
I don't know.
Well, we're gonna show up. I need to duct tape my cleats back together.
Oh, alright.
Let's say wear these another day.
I don't understand how this thing works.
I don't
Yeah.
either. I'm still trying to get it to even pull up. I'm just super confused on what the question's still asking.
I've been saying something and stopped.
Yeah.
Yeah, you're good by class.
Yes, I'm in a class right now.
I'm sorry. He said, "Oh, class can hear us."
Hey, are you there?
Stop. You guys. Sorry, don't mind my roommates. They're just being dingus wads.
Ugh. I'm trying to figure out when it says parent population, does that mean the original population that they were talking about, and then they're taking another sample of just the parent population?
I think so.
Because if we're thinking central limit theorem like it was talking about in the notes, the smaller the sample size, or the smaller the mean of the sample, the less likely it is to be a normal distribution.
Right. Yeah, no, I remember that now.
I feel like with number 4, it would be normal because the sample distribution was huge.
Right. Yeah, I can see that.
That's fine. So is just the next one going to be normal then too?
So kind of just looking at question 8, just looking through the whole group assignment, and it talks about the central limit theorem, and talks about that exactly. You know, it's the larger the number, the more normal it becomes. So yeah, that makes sense.
Please don't freeze. So if we do number 5 then, since the parent population is normally distributed, but the sample number is only 5, would it stay normal since the parent population is normal?
That's what I would
I
answer.
think so, because you can't tell. If it's going to be skewed, there's no way to tell which way it would be skewed.
Right.
So, that would go with normal.
Okay. So
So for sorry, keep going.
And 6
So
would
number
probably be the
number
same.
6 would be normal.
Yeah, that one definitely would be normal. Okay. So for 3, would it be?
I feel like number 3 would be skewed
Number,
because
would
the
it-
sample
so it
number
would be
is so
right
small and the
skewed?
parent number.
Oh, right, okay. Got it. Cool. So we're on 7 now.
Yeah. So this is basically something else
yeah.
that we have from earlier.
So when would the distribution of means be normally distributed?
Maybe the 3 times we said it. Right?
When the data drawn from a population is distributed. I would think it would be at least B. The second choice makes sense. And then last one too.
Yeah.
So it'd be like where B and D were.
But wouldn't the first one be right too? Because we agreed earlier that there's 3 normals. And it's basically summing up, that's what I understand.
What
Wait,
does
what?
the? Oh, sorry.
Like the top one says, when a population is normally distributed and a sample size is small, wouldn't that be up there too?
Yeah, true. That one would be normal still too. So the only
It would.
normal is when it's skewed right and small sample size.
The only one that we're not putting the check mark for is the third one.
Yeah, that's the march.
Okay.
Alright, and the third one, just to make sure we all have the same order of questions, it says data are drawn from a population that is right skewed and the sample size is small. That's the third one?
Yeah.
Yes.
Okay, cool. So we're doing the right one. So everything but that one. Alright, so 8.
Yep, number 8. Oh, it's the central limit theorem. Okay. You have the best explanation of the central limit.
Isn't this one where more people?
I'm pretty sure it's as large the shape of the sampling distribution as the sample mean of x bar will be approximately normal.
Yeah.
Oh, that's right.
'Cause the other one is the law of large numbers. So yeah, that's the last one. Yeah. Nine. Quite a little math.
So number 9, if x is a random variable with a population mean of 10 and a standard deviation of 6, suppose a sample size of 36 is drawn from the population. What is the mean of the distribution of sample means?
That would be
So it's basically asking what x bar.
Going to be wrong.
So how did we do that again, though?
It's the one where, isn't it that the one where you did the square root and you find that's like the question. You do the standard deviation divided by the sample, with the square root of the sample.
So it would be 10 divided by the square root of 6?
I thought, well, in the homework one we did the standard deviation divided by the square root of the sample size.
Okay, so it'd be 6 divided by the square root of 36.
So I'm looking at it. Someone else should check it too. That's what I'm understanding. From what I understand, the answer is 1, but someone else should.
Yeah, I got
But see, that's what I got if I do it that way.
Yeah.
But you should check to make sure that's the way we're supposed to do it.
Yeah, that's the thing is I have no idea how we're supposed to do this, and that's why I didn't understand it on the homework either.
Right. So let's see.
What is the mean of sampling distribution? Maybe I read the question wrong.
The mean is 10. I got a question?
Mean of the sampling distribution. Maybe I did.
The mean of the distribution
Well, shouldn't it just be the 10 then?
x bar, which would be the sample mean. So that's what we have to solve for.
Right. Which, yeah. For that, I got 1 also.
But I don't think we did it right.
Yeah. 6 divided
So
by the
what
square root of 36.
Well,
So it'd be 6 over 6, which is 1.
Yeah.
what's it actually asking is the question. Okay.
Okay, so what is the standard deviation of the
Well,
distribution
that's
of
how we
sample?
find this.
What was that?
That's the standard deviation one, actually.
What we just found out for 9?
I think so. I'm looking at the homework and what we went over, and I'm pretty sure that's what that is.
Oh.
Trying to figure it out.
I'm super confused now. So was number 9 1 or is number 10 1?
I think it's 10.
Oh, yeah, I think he's right.
Because number 9, the mean of the distribution, Because in D in the homework, we were trying to find the standard deviation, and that's what you would have to do.
I think it was just trying to find the mean of the sample distribution.
What's the standard deviation of the sample?
What is the standard deviation of the sampling distribution of the sample mean?
Mean of the distribution of samples.
Mean of the sampling distribution. Because in the homework it says that the mean of the sampling distribution of the sample mean is equal to that of the population.
Oh.
It says the sample mean is equal to what?
The population. I'm looking at the answer sheet from the homework, and that's what it says.
So for number 9, it would mean that the mean distribution of sample means would also be the population mean at 10?
That's what I'm understanding. So if you want to look up the homework that we did, someone else can check it too to see if I'm reading it right.
Alright.
Yeah, I'm completely lost, and I can't get the answer key to download, so I have no idea what you're talking about
Okay.
as regards to the answer sheet.
Let's see if we can pull it up.
Okay, have you been able to pull it up yet?
It's pulling up right now.
I've got it right now.
No, my computer's been slow too.
Well, we can work on the next two while it's pulling up, I think.
Yeah, mine's going dumb,
Yeah,
so
that's-
let's just keep going. Yeah.
Okay, so number 11 then. Regardless of the distribution of the population, if the sample size is large or larger than 30, what would be the of the distribution of the sample mean? I would say it says sample size is large would be normal.
Yeah. Okay, okay.
And it would be the central limit theorem
Yep.
to justify it, right?
Yeah. That's enough.
For number 12.
That's the central limit theorem. 12.
Yeah.
And then what about this? Just these guys.
All right. So what were we looking for 9? Was it?
Yeah.
Yeah.
The mean of the distribution of sample means, I think it was like 7C or something like that.
17. Okay. Mean of sample. There's not really. It's weird.
Did you pull up the thing yet?
Yeah, the answer key. Yeah.
Yeah, it's in question 8. It's C and D.
Oh,
Is what I'm looking at.
yeah. So see, the answer of that is just. Oh yeah, okay. It's equal to that of the parent population. Yeah.
So that's the first one, right? So
Yeah.
that's when we're looking at number 9, right?
Yes.
So the answer is for
Yes,
number 9 is
let X be
10.
the random variable with a population mean of 10, and a standard deviation of 6, with a sample size of 36 people. So what's the mean?
Mean of the sample. Yeah, I think it's just 10. Like it's equal to the other one.
That's what I understood, okay.
Yeah.
And then the standard deviation is what I said earlier, right?
Yeah, 1.
Yeah.
After doing the calculation.
Yeah,
So,
And I think we got it.
right?
Yeah.
actually, yeah, that makes a lot more sense. Yeah. Standard deviation.
So the mean is,
Okay.
and the standard deviation is 1.
Yep.
Yep.
Yeah. So 9 is 10. 10 is
1. So, is that it? Oh, yeah, that's all of it.
So 9 and 10 is 1.
yeah.
Uh-huh.
Wait. Oh,
And
for
9 is 10.
Yeah.
And 10 is 1.
Question 9 is
So
10.
the population mean in this instance is also the same as the
That's the distribution.
Yes.
Okay. So, you guys want to go over anything again, or are we good?
Let's just make sure we got the same answers.
I mean, I think
Okay. So
the answers,
3 we
I'm
put
still confused on 9 and 10.
stupid, right?
Okay.
So for 3 we put skewed right.
Mhm.
4 we put normal.
4.
5 we put normal.
Okay.
6 we put normal. 7 we put A, B, and D.
Okay.
8 we put D. 9 we put 10. 10 we put 1. 11 we put normal. And 12 we put central limit theorem.
Okay.
Is that what everyone got?
I think so. My computer's slightly frozen.
Oh,
Oh. Okay.
we can do this.
So number 7, but the answer where C would be off, and then number 8 we put B. 9 is the answer is 10. Number 10 the answer is 1.
Yep.
Number 11 it's normal, and number 12 it's the central limit theorem.
Yes.
Yeah.
Okay, well then I'm pressing submit.
All right.
How do we do? Mine's taking a while to submit.
Oh, 100%.
We did?
Yeah.
We got 100?
Yep. We got a
Yeah.
100.
Yay!
Holy dang.
Okay,
That
cool.
was a little bit of a surprise.
That's good.
I was not so sure about that one, so that's good.
Yeah.
Alright,
So,
well,
Well, job well done.
yep.
do you guys anything else? I don't know if I'm going to be a whole lot of help, but I can try.
For what?
Yeah. Well, mine's the
I
better.
said, does anyone need help on anything else? Because if not, I can just submit the video real quick.
I think I'm good.
Yeah, I think should be good. Yeah, I think the only thing we have to do is the homework.
Because
Yeah.
Yep.
Yeah.
Alright, we'll see you guys at noon on Thursday.
All right.
Thursday
See you
at
guys later.
12:30.